Okay, so this is linear motion problems for all levels, right? For all levels. So I'll read the question out loud, okay? So the question is saying that draw a graph of velocity against time for a body which starts with an initial velocity of 4 meters per second and continues to move with an acceleration of 1.5 meters per square second for 6 seconds. So acceleration A is equal to 1.5 meters per square second, right? For 6 seconds, which means the body was increasing in speed for those 6 seconds, right? Then initial velocity u is 4 meters per second. So let's see what the graph looks like. Okay, so the graph will look like this. So the question is saying sketch a velocity time graph. Okay, velocity against time, right? Velocity against time. So this is the velocity in meters per second, and this is the time in seconds, right? So after you're done, you start factoring in the variables now. So we have the velocity variable and we have the time variable. So the body is initially moving at 4 meters per second, right? Then it continues to accelerate to increase in velocity. Whenever a body is accelerating, is increasing in velocity. So the body is moving with an acceleration of 1.5 meters per square second for 6 seconds. So it starts from 4 meters per second and start moving with an acceleration gaining in velocity for 6 seconds, right? For 6 seconds. So from 0 to 6, that's when the body was accelerating. So that's all the question said about this scenario. So we have our graph now. We have velocity, we have acceleration, then we have time here. It accelerated for 6 seconds. Then you're done. So let's pay attention to the question now. Let's get into the question. Okay, so question 1 is saying that show how you would find on the graph the average velocity, right? The average velocity. So if you can see here that the velocity is constantly increasing, right? From 4 up to unknown, the velocity is constantly increasing. So we want the average velocity. So how we can find the average velocity? The average velocity is equal to v plus u over 2. That's the average velocity. The average velocity is going to be equal to final velocity plus the initial velocity divided by 2, right? So the initial velocity, obviously we have the initial velocity is 4 meters per square second, right? As we've been told from the question, which is 4 here from the graph, right? But we don't have the final velocity. The body was gaining in speed to 100. The body is gaining in speed, but we don't know where it was when it reached this point. Kuti velocity yangasvika pa which value. So we are going to calculate what velocity will be after the 6 seconds it was accelerating. Okay? So how can we find that? How can we find the final velocity here? So we have this equation, first equation of motion, which is A is equal to V minus U over T. Right? This equation stands for acceleration is equal to final velocity minus initial velocity over time, right? So we are going to make V the subject of the formula since we want to find the final velocity at the top of the graph, okay? So what we do here is we make V the subject of the formula. So if you don't know how to make a variable the subject of the formula, I have a tutorial on that. I've left a link in the description. You can just click that link and it will take you to my tutorial on making a variable the subject of the formula. So without wasting much of your time, let's get into it. So to make V the subject of the formula here, obviously we're going to end with A. We're going to end with AT plus U is equal to V. Right? If we make V the subject of the formula, we're going to end with AT plus U is equal to V. Okay, I told you kuti vasingaziva how to make a variable subject of the formula, go check out my tutorial. I've left a link in the description. It's just for you. For Form 4s, O level, Form 4s and Form 3s, O level. And so obviously we're going to find V at the top of the curve is going to be equal to A times T plus U, right? U is the initial velocity. So A A is what? The acceleration. The question is told us that the body moved with this acceleration. A, this is A, which is the acceleration, 1.5 meters per square second. Okay, so but takungobvisa variables tichiisa values, right? When you're substituting the variables with their values. So A, acceleration is the body was moving with an acceleration of 1.5, right? Then for what? T stands for time, for 6 seconds, right? Plus U, which is the initial velocity the body was moving at, which is 4. So this is equal to U. So 1.5 times 6 is equal to 9. So 9 plus 4 is equal to U, is equal to V, the final velocity. So you can see that 13, at the end of the 6 seconds, the body was accelerating, it reached 13 meters per square second. So we can now see on the graph that at this point, for 6 seconds, the body was accelerating, it reached 13 meters per second. I hope that's clear to everyone. So this is now the graph. The body was initially moving at 4 meters per square second. Then it was accelerating for 6 seconds. For the 6 seconds it was accelerating, it increased in velocity to 13 meters per square second. Okay, so the reason why we calculated this 13 is that the question is asking us to find the average velocity. With the average velocity, VA is equal to the final velocity, which is 13 meters per second, plus the initial velocity, which is 4 meters per second, divided by 2. Okay, so obviously the average velocity is going to be equal to 13 final velocity plus 4 the initial velocity divided by 2, right? Okay, so as a result, the average velocity is going to be equal to 8.5 meters per second. And so I'm gonna see my units. And so kana uchicalculate unogona kusiya kuma units, but kana wapedza kucalculate ukuzoti ucalculate, maybe ucalculate time at the end uchiisa s for seconds. Kana uchicalculate velocity at the end uchiisa meters per second, since ndo my units acho. So 8.5 over 13 the final velocity plus 4 the initial velocity over 2. So because that average velocity is equal to the final velocity plus the initial velocity over 2. So apa papesi apa paapa kusvika pesi apa tanga tichicalculate the final velocity at the top of the graph, kuti the body painge accelerator for 6 seconds kusvika pamusoro apa inge again a speed of g. So we've calculated that. Then we found that the final velocity at the top of the graph is equal to 13 meters per second. So tawana final velocity yedu manje, and I'll call it average velocity, which is equal to average velocity, which is equal to final velocity plus initial velocity over 2. So tawana final velocity yedu 13, plus the body was initially moving at 4. So 13 plus 4, which is 17, divided by 2, the average velocity is going to be equal to 8.5 meters per second. So let's move on to question 2 now. Okay, so we've moved on to question 2, so we've calculated the average velocity here with our the average velocity 8.5 meters per second, with the average velocity. So the question 2 now, item 2 is now saying that show on the graph how you would find on the graph the distance moved in 6 seconds, right? The distance moved in 6 seconds. So 6 seconds, the only time engage move, right? And from the question, the body only moved for 6 seconds, right? So you take your graph now, right? Do graph read again, and so this area under the graph, the distance. So when it linear motion, we have my equations of motion, about 4 equations of motion. You can use one of the equations to find the distance moved, but in this case, find it from the graph. That's what the question is saying, all right? So this area under the graph is the distance moved. If it's a velocity time graph, right? This is velocity against time. So if it's a velocity time graph, the area under the graph is the distance moved, right? So if you take a look at this shape, this is a trapezium. You can call this side A, right? So on side A and call this side B, right? So side A and side B, right? So area of a trapezium is equal to what? And we can call this the height. Okay, so we're gonna put the paper like this, right? And we can call this the height. So this is side A, side height, and side B, right? So area of a trapezium is equal to half A plus B in brackets times height, right? This is the area of a trapezium. Half A plus B times height. So we're just saying that in this case A is equal to what? 0 to 4 is A. So in this case 0 to 4. Okay, so let's ngatingonyore values variables per side kuti munyatsoona ndini. So kubva pana 0 kusvika pana 4, this is side A. So side A is equal to 4. So A is equal to 4, right? And then side B from 0 to 13 to side B. So both kubva pana 0, right? This is the y-axis, 0 to 13 to side B. Kubva pana 13 apa, right? The final top of the graph, and it 13 kusvika pana 0, and it along the y-axis. This is side B. And so side B yakareba 13, right? Then h the height now from 0 to 6 on the x-axis. Chitongoti ndapindurudza graph kuti munyatsoona ndizvo. Ndapindurudza graph kuti muone kuti it's a trapezium. So tongotsvaga area yetrapezium. So from 0 to here is 6, and so h is equal to 6. So wapedza kapa, and so which means the distance x is equal to a plus b divided by 2 times h, and so a is equal to 4, b is equal to 13 divided by 2 times 6, since h is equal to 6. So ultimately x is going to be equal to what? Okay, so 4 plus 13 is going to be equal to 17 divided by 2, which is equal to 8.5. 8.5, then times 6. So 8.5 times 6 is equal to 51, if I'm not mistaken, 51 meters. So x, the distance, is going to be equal to 51. Wapedza question. Waturova Zimsec. So we are now moving on to the second question now, right? So pay close attention to whenever varwa by this graph. On the second graph, I'm going to be a little bit slower. Okay, so question 2 is very, very interesting. So I want you to pay close attention. So let me read the question. A car travels at uniform velocity of 20 meters per second for 5 seconds. The brakes are applied and the car comes to a stop with uniform retardation. Retardation means the car started to decelerate in a further 8 seconds. So this retardation happened for further 8 seconds after the brakes were applied. Okay, so question 1 is saying, sketch a graph of velocity against time of this entire scenario. Okay, so a graph of velocity against time. This is an easy one. Okay, so after you're done sketching the graph, it will look like this, right? So it's a velocity time graph. This is the velocity in meters per second, and this is the time in seconds. Okay, so the question saying that the body was moving at 20 meters per second for 5 seconds, right? So the velocity was constant for 5 seconds, right? So this is 20 meters per second, right? This is the velocity, 20 meters per second. It moved with 20 meters per second for 5 seconds. So for 5 seconds unto this time period, for 5 seconds, it was moving with 20 meters per second. Then the brakes were applied. Then from the moment the brakes were applied, the car started to decelerate or decrease in speed, right? So from this point to a further 8 seconds. From 5 to 13, there is a difference of 8, right? So from 5 for a further 8 seconds, the body was decreasing in speed until it reached 0. Then it came to a stop, right? Whenever a body is at a stop or at rest, the velocity will be 0. Okay, so that's the graph, which means question A, you're done. You've sketched your graph. This is the complete graph. Okay, so let's answer further questions now. Okay, so question A, Tapis and I, we're done with question A. We've sketched the graph, so we're going to put a tick here. We're done with question A. So we are now attempting question B of the same scenario. How far does the car travel after the brakes are applied? Okay, so we're going to use the graph to solve this question again. So pay attention here. I want you to pay absolute attention now. So the brakes were applied at this position, right? After that position, the car moved for a further 8 seconds, right? But we are not told how far it traveled. For further 8 seconds from 5 to 13, and from 5 to 13, the car was moving and came to a stop at 13, right? So, how far did the car travel from the point the brakes were applied? So, this is very simple. The area under this graph, starting from 5 to 13, the area under this graph is the distance. If the graph is a velocity time graph, right? Whenever it's a velocity time graph, the area under the graph is the distance traveled. So the question is not demanding the entire distance the car traveled. No, it wants the distance the car traveled from the position the brakes were applied to the further 8 seconds. So the brakes were applied at this position. I will repeat again. And for the further 8 seconds, 5 plus 8 is equal to 13. For the further 8 seconds unto 13, the car was still moving. It came to stop at this position. So how far was this? So obviously this is a triangle. Area of a triangle is half base times height. So from 5 to 13 is the base, right? Which is a difference of 8. So okay, let me draw the triangle here. Okay, this is the base. This is the base, right? So the base is 8, right? And the height is what? The height is the y-axis is from 0 to 20, right? This is the height, right? And I hope I'm speaking to intelligent people. The height is from 0 to 20. This is the height. So the height is what? So the base is equal to 8. The height is equal to 20, right? The area under this shape, the area under this graph is what? Is the distance traveled. So half of base times what? So half of 8 times 20. So obviously 2 into 8 is going to be equal to 4. So okay, so we're already seeing that 4 times 20 is equal to 80. So the car traveled 80 meters from the position the brakes were hit. That's the area under the graph. So the car traveled a further 80 meters from the position the brakes were hit. So that's your answer, right? Which means question 2 is done now. Question 2 is done. Question 2, we have sketched the graph. Sketch a graph of the velocity time. That's done. And how far does the car travel after the brakes were applied? That's also done. So we are now moving on to question 3 now. The last question. Okay, so as you can see that question 3 has nothing to do with graphs. So let me read the question. A motorist traveling at 90 kilometers per hour applies the brakes and comes to rest with uniform retardation in 20 seconds, right? So the question is saying that calculate the retardation in meters per second. That's the unit for acceleration or retardation. Retardation just means deceleration. So retardation is acceleration with a negative sign, right? Because the acceleration is decreasing, right? So this is a very easy question. The only tricky part about this question is that it's in kilometers per hour. In kilometers per hour, if we convert them to meters per second, it would be just 20 meters per second, right? So how did I find that? So 90 kilometers is equal to 90,000 meters, right? 1 hour is equal to what? 1 hour is equal to 3600 seconds, right? 3600 seconds. 3600 seconds means that 3600 seconds. All right, so if you divide both sides by 3600 seconds, 3600 seconds, right? It's going to be equal to the second here. Then 3600 into 90,000 is going to be equal to 25 per second. So it's going to 25 meters per second, right? So 90 kilometers per hour is equal to 25 meters per second. I hope that's clear to everyone. So the question is saying that calculate the retardation, and I've said it and I'll say it again. Retardation is just acceleration with the negative sign. All right, so let's calculate the acceleration. We know that from our equations of motion, so from our equations of motion, A is just equal to V minus U over T. A is equal to V minus U over T. Acceleration is equal to the initial velocity, the final velocity minus the initial velocity over time, right? So when we find the initial velocity chi, final velocity chi, though it speaks for itself. Okay, so the final velocity is 0. How do I know that? So the brakes were applied and the motorist came to rest with uniform retardation. So to rest means the body came to a stop. That's what to rest means, right? So V is equal to 0. So A is equal to 0 minus the initial velocity, right? The initial velocity, initially the motorist was traveling at 90 kilometers per hour, which we translated to 25 meters per second, which we converted to 25 meters per second. So it's going to be equal to 0 minus 25 over what? Over T. So the motorist was decelerating for 20 seconds. Right? For 20 seconds, right? So T is equal to 20. Okay, so if you're saying, let me take a clear sheet. So our equation is now saying A is equal to 0 minus 25 over 20, right? 25 over 20. Okay, so pay very, very close attention. Okay, so 0 minus 25 is just equal to negative 25 over 20. So A is equal to this. A is equal to negative 25 over 20, right? A is equal to negative 25 over 20. So if we divide negative 25 by 20, we're going to end up with A is equal to negative 1.25. 1.25 meters per square second. This is the part I wanted you to pay close attention to. Okay, so the question said that calculate the retardation in meters per square second. Retardation is just acceleration with the negative sign. So we are saying that the acceleration is equal to negative. Why negative? Because it's retardation. It's decelerating, right? So A is equal to negative 25 over 20 is equal to negative 1.25 meters per square second. How did we find this? A is equal to V minus U over T. And A is equal to V minus U over T. Tatawana isusu that A is equal to V minus U over T. Right? Then we found out that what? V is equal to 0 since the car came to a stop. Right? So since V is equal to 0, so A now is equal to 0 minus the initial velocity is 25 meters per second. Over what? Over T, which is 20 seconds. From what the question told us, that the motorist was moving with retardation for 20 seconds, was retarding for 20 seconds, right? So obviously A is equal to negative 25 over 20. A is equal to what? Negative 1.25 meters per square second. Zimsec. Very easy. Kinematics is very easy. Okay, so so to those vasinangonzwisisa and to those vasinangonzwisisa do ndoshandiswa nokushandisa chii just leave your email in the comment section. Then I will contact you and you tell me what where you got lost. Okay, so you can just leave your WhatsApp number or your email. They can talk to you directly and assist you directly, okay, on your individual weaknesses. So subscribe and stay tuned.